In this video, we're going to discuss the very introduction to the graphing calculator in Desmos. This is an absolutely beautiful piece of software that was designed for simplicity and for a very specific purpose of being able to quickly generate graphs and examine the effects of parameters. So let's just begin. Usually you can type in y equals, this is the input bar here. You can type in, let's say, y equals 2x. And you notice that if I want to just type in the y equals 2, it shows you what that function looks like. Then when I multiply the 2x, you can see that it becomes a line. So that's pretty cool right there, just to get the idea of how quickly something goes up there. Now let's say that you're working with the 9th graders and you want to investigate what happens when the slope changes. Well, you just type in y equals mx, and then it says, oh, would you like a slider for m? And it puts a slider for m there. And now you can see what happens when it's negative, when it's positive. And obviously the question here, I think, is not to say, hey, look what happens when I do this, but to say, what do you think will happen? Right now it's negative. Why do you think that happens? As we make it less negative, what's going to happen? So you ask them to predict before they do it, and then to explain, okay, so it looks like the slope is, what's happening to the slope is getting less negative. What does that mean? And then here, gee, do you think I can ever make it go all the way to the vertical line? Why is that? Why does it jump fast here and then all of a sudden it goes a lot slower all the way up here? Asking these why questions as opposed to just look what happens when I move the slider makes a big difference in terms of effectiveness in the classroom. There's a couple other ideas here. Let's go on to continue to be looking at parameters. Suppose you want to hide these now. You just simply click like this and that hides them. You can bring them back later. Suppose that you wanted to show a parabola. You can just say y equals ax squared. Now that's asking me, do I want a slider for a? Well, yes, I do. Thank you. So again, you can just move this around, but woo, 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 why? Wow. So say, for example, what's happening? It looks like it's getting fatter as I move this to smaller and smaller numbers, right? What's really happening here is that for any value, let's take a look at 2. So now I want to move on to how you plot points, just so that you can take a look at why this phenomenon of making it look fatter is really occurring. So let's just take a look at 2. Suppose I want to put a dot on the function at x equals 2. So I'm going to change this function just slightly. Instead of calling it y, I'm going to call it f of x. It's now f of x equals ax squared. So now I'm going to plot the point 2 comma f of 2. Notice that this is exactly like the normal nomenclature that you would use. Now you can see that here's the point 2 comma f of 2. So now as I move the a parameter here, you can see that what's really happening is actually that for it's not getting fatter or skinnier per se. What's happening is that the y values, see, the x value isn't changing. The y value is getting smaller because you're multiplying it by a smaller number, and now we're multiplying it by a larger number. So when they say that the parabola is shrinking or stretching, I really don't like that language, because what's really happening is the y value is being dilated by this parameter a here. So that's a little bit of an example of how you can quickly use parameters and sliders. Now, another thing that you can do with the points is you can actually make your own free point. So let's just make a point p comma q. Okay, now right now it's at 1, 1, but I can actually move it anywhere I want, and you can see the sliders on the left are actually moving. So there's 1 point. Now let's call this, suppose we want to make a point on a vertex of just a general parabola. So we know that the equation for a general parabola is a times x minus h squared plus k. So let's make a point h comma k here. Now let's just say I want to call this the vertex. Okay, I can actually, I'm going to click here where it says label, and I'm going to call this vertex. Okay, and then I can click on this one here, and I'm going to call this point on, oops, P-O-I-N-T. Okay, so my first challenge to you is this. So far we have a function here, y equals ax squared, and we put a point on it. Now what I want to do is to be able to move my vertex around and have a point on the parabola, and I want to be able to have a parabola always go through this vertex and this point on the parabola. So I'm going to stop the video and give you a chance to take up that challenge, and I will solve it in the next video.